Section 5.2 talks about normal distributions and how to find probabilities. So let's take a look at this little first paragraph that I have right here and let's see what we can figure it out. Probability in normal distributions. It says, as mentioned in the previous section, we can find the probability that a random variable x will lie in any interval by calculating the area under the curve for that interval. Any non-standard normal curve interval can be converted into a standard normal curve interval by converting the upper and lower boundaries of the interval to z-scores. It says, consider the figure below where a non-standard normal curve has a mean of 500 and a standard deviation of 100. So, guys, what we're going to be doing here is we're going to be taking something that has a normal distribution and we are going to convert it to the standard normal distribution because this here is uniform and we can find different probabilities. So as long as we have a normal distribution, we can convert everything into what we call z-scores. And z-scores are used in the standard normal distribution. So just a couple of things to remember. Let me get my eraser here. In the standard normal distribution, the mean is always 0, and the standard deviation is going to be equal to 1. Okay, so I'm going to show you what I mean by this by doing the first problem that I have here. I'm just going to kind of move this over a little bit. All right. And it says the average speed of vehicles traveling on a stretch of highway is 67 miles an hour with a standard deviation of 3.5 miles an hour. A vehicle is selected at random. What is the probability that it is violating the speed limit of 70 miles an hour? Assume the speeds are normally distributed and are represented by the variable x. Okay, so in this particular problem, we know that our mean is 67, and we know that our standard deviation is 3.5 because it tells me right here the average speed is 67 and the standard deviation is 7.5. Okay. The question here is asking me, what is the probability that it is violating the speed limit of 70 miles an hour? Okay, so what we're trying to figure out, if we're looking for the probability that it's violating the speed, we pick a car, right? We pick a vehicle. We're trying to figure out what's the probability that it's violating the speed limit of 70. Wouldn't that mean that the speed of the car would have to be greater than 70 because that's what it means to be violating the speed limit? Okay. So what we're going to do is we're going to convert our x value of 70, we're going to convert that to a z value. Okay. So I'm going to kind of scroll up just a tiny bit here. Okay. The reason I want to do that is I want you to see what we have right here. This is the formula that we used in 5.1. So I'm going to say z is equal to x minus mu divided by sigma. My x value in this case, guys, is 70. So I'm going to write 70 minus 67 divided by 3.5. Okay. So let me grab my calculator. Let me turn it on. There we go. Clear it. Let me move it over here a little bit. So I'm going to go 70 minus 67 equals divided by 3.5 equals, okay, so with the z values, guys, because I'm finding a z value, if you remember from 5.1, I'm going to pull up the table right now, but here are my z values. So if you notice on my z values, let me see, yes, okay, so here are my z values. So when I look at this one here and this one here, what that really means is that z is negative 3.49, and so the area under the curve would be something like 0.002, right? But the point I'm trying to make here is look at how many decimal points we have. After my decimal point, I have 2 values, right? So my z values, let me bring this back up. My z values, I'm going to round to 2 decimal places. So 2 decimal places, that would be 0.86, okay? 0.86. So what we're going to do now is we're going to see, can we find the probability, instead of saying x is greater than 70, we're now going to say z is greater than 0.86, okay? Now, I want you to think about my standard table, which is this one right here, okay? I'm going to draw that same chart, that same graph right here, okay? So this is 0, right? My standard deviation is going to be 1 because in the standard normal distribution, my mean is always 0 and my standard deviation is always 1. Okay, so suppose here is the number 1. If we're looking at 0.86, 0.86 would be pretty close to 1, wouldn't it? Somewhere right there, 0.86, okay? And we're trying to find the area to the right. Now, the only thing is, if I'm going to use my chart, my graph, my z-table, the z-table always tells me what's the area going to be to the left, okay? So all I'm going to do, I'm going to show you what I'm going to do here. I'm going to come back to my chart. I'm going to go to 0.86. Okay, where is it? Let me scroll up just a little bit. Okay, so here's 6. Oh, those are negatives. We want the positive ones. Oops, my bad. Oops. There we go. Okay, we want positive 0.86, so here's 0.8. Here's 0.6. And I'm looking at right here, 0.8051. Okay, what that's telling me is that the area over here is 0.8051. But remember, I'm actually trying to find this area. If you remember, the area underneath the whole curve is going to be equal to, it's going to be equal to 1. So if I wanted to find the green part here, this area, then all I would need to do is take 1 minus 0.8051. I can do that on my calculator. So 1 minus 0.8051. And I'm coming up with 0.1949. Okay? 0.1949. So this is how I would do this problem if I decided that I wanted to use my table. Okay? So the second part is, well, what happens if I didn't want to use the table and I wanted to use my calculator? Okay? If I was going to use my calculator, remember what we're looking for. Right here, we said that number was 0.86. And we're trying to find the area from 0.86 all the way to the right, right? So remember, the right, I'm going to keep going all the way to hit infinity. Well, I can't enter actually the number infinity in my calculator, but what I would do is I'd come back over here, clear it out. I'm going to go second in vars. I'm going to go to the normal CDF, okay, enter. The lower limit, what I mean by the lower limit is, look at what we're starting. We're starting right here at 0.86. So I'm going to go 0.86, comma. Where am I going to end? Well, I'm going to keep going as far as I can go. So I'm going to enter in a few nines, okay? And then I'm going to hit enter, and I should be coming up with 0.1949. And if you notice, it's 0.1948 with a 9, so if I round it to 4 decimal places, 0.1949, okay? Before I get to part 2, people often ask, which is the way I should do it? The way you should do it is the way that you feel is easier for you. If you like using the calculator, then that's exactly what I want you to do. If you feel like the table is better fitting for you, then that's exactly what I want you to do. You got to find one of those two. Those are the two ways you can do it, right? So sometimes people say, well, you know what? Neither one was easy. Well, you got to find the one that's easier, okay? But that's basically how I'm going to be doing these problems, okay? So we're going to go through a few more so that we get the hang of this here. Number 2 says, the monthly utility bills in a city are normally distributed with a mean of 100 and a standard deviation of 12. A utility bill is randomly selected. Okay, so before I even get to part A, we know that our mean, is 100, pardon me, and my standard deviation right now is 12, okay? So I'm going to start with this first because those are two important pieces of information. Part A says, find the probability that my utility bill X is going to be smaller than 70. So what I need to do first, guys, is I need to convert this X value into a Z-score. So my formula is Z equals X minus mu divided by sigma. My x value here is 70, so I'm going to go 70 minus 100 divided by 12. So I'm going to grab my calculator so I can do this. So 70 minus 100, it should be negative 30, right? Oh, come on, come on, pen. All right. Divided by, what do we say, 12 equals 2.5, negative. Okay, so z equals a negative 2.5. All right. So now what I'm going to do, we're now looking for the probability that z is less than negative 2.5, okay? So again, what I'm going to do, the first thing I'm going to do, guys, I'm doing this part because I want you to see visually what it is I'm trying to do, right? So here's my normal curve, right? Here's my mu equals 0. The z value we have is negative 2.5. So this is like, say, negative 1, negative 2, negative 3. Right here is negative 2.5. And because, let me just scroll back a little bit to the left. There we go. Because we're looking for the probability that z is less than, we're looking for that area to the left, okay? So again, if I was going to use my table, the first thing I'm going to do is pull up my table. I need to go to negative 2.5. Okay, so here is negative 2.5, and the last digit is 0, so it's going to be this one here. So it should be 0.0062. And so my answer for part A would be 0.0062, right? And if you say, okay, well, suppose I wanted to use my calculator. Well, how would I do this on my calculator? I'll show you right now. So remember, excuse me, we are finding the area to the left, right? So I'm going all the way this way. So remember, I'm going from negative infinity, and I'm going to stop at negative 2.5. So I go to my calculator, I'd hit second, vars, go to my normal CDF, hit enter. If I'm over here at negative infinity, remember I'm going to enter a negative and a whole bunch of nines, comma, negative 2.5, and close that off and hit enter. And I'm coming up with 0.0062, and that was the same answer that we had right there. Okay. So again, which way is easier for you? That's up to you to decide. Okay. Some people like the table, some people like the calculator. I'm showing you how to do it both ways, okay, just so that you can choose. All right. So part B says, find the probability that the utility bill is between $90 and $120, okay? Between $90 and $120. All righty. So between 90 and 120. Okay, so we can do this again. First thing we're going to do, we're going to convert our x values to z-scores. Okay. So I'm going to call it z1 for the first one here for 90, okay? So I'm going to say this is 90 minus our average was 100, and our standard deviation was 12. Okay, so that's going to be negative something or another, negative 10 over 12, I know that. Negative 10 divided by 12 is negative 0.83. Okay, and then I'll do my second z value, which is going to be the 120 minus 100 divided by 12. So I know that 120 minus 100 is 20. So 20 divided by 12 equals, and I'm coming up with 1.67. Okay. 1.67, okay. So I'm going to just kind of move over to the right because I am running out of room here. I should have given myself a little bit more room, but that's okay. So first thing I'm going to do, draw my little curve here. Okay, here we go at 0, and I'm looking at negative 0.83, negative 0.83 to 1.67. Okay, so one thing I want to mention, when I use my table always tells me the area to the left. What we're trying to find right now, we're trying to find this area. We're trying to find the area in the middle because we want it to be between those two numbers, okay? If I use my table, when I find my table, when I go to the negative 0.83, that's going to give me the area to the left, okay? So I'm going to pull up my table, negative 0.83. So just to give you a heads up, there's my 3, negative 0.83. Let me see if I can find it on here. And I'm coming up with 0.2033, okay? So that's going to be 0.2033. Now, when I do it for the 1.67, that's also telling me the area to the left. 1.67. 1.67 would be right here, 0.9525. So now what I'm going to do, 0.9525, and I'm going to subtract those two numbers, okay? So 0.9525, minus 0.2033 equals, and I'm coming up with 0.7492. 0.7492. That's the number that I'm coming up with so far, right? Okay, because remember, I was finding the area in the blue, right? So when I found the area originally for 0.83, that gave me the area to the left. When we did it for 1.67, that gave me that area to the left. So if I wanted to find the area in the blue, then I had to subtract those two numbers, correct? All right, now we might say, okay, well, hold up. I like using the calculator. How am I going to do this? Easy breezy, cover girl. I'm going to go to second vars. I'm going to go to my normal CDF. I'm going to hit enter. The first number I have is a negative 0.83, comma, 1.67. Close off my parentheses. Hit enter. And 0.749, I guess I would round it up to 3. But again, I'm off by tens, hundreds, thousands, by a 10,000ths of a point, right? And we did do a little rounding when we came up with those numbers right there, but we're in essence coming up with the same number, correct? All righty. So let me move over because I'm still on problem number 2. It's a long problem, isn't it? And let's do the last part. The last part, part C, says, what's the probability that my utility bill is going to be more than $140? Okay. So remember what I'm going to do. I'm going to convert my X value to a Z-score. Okay, so I'm going to take 140 minus 100 divided by 12. So 140 minus 100 is 40. Let's divide that by 12. And I'm coming up with 3.33. Okay, 3.33. So what we're looking for now is what's the probability that Z is going to be greater than 3.33. Okay, so if I were to draw my normal curve, right? Here we go. Here's 0. Remember, there's my standard deviation of 1, standard deviation of 2, standard deviation of 3. And we're looking at, in this case, 3.33. And because it says greater than, we're looking for that area to the right. Okay. Remember, though, my table always tells me the area to the left, okay? So if I were to come up with my table, come back over here, here's my table, 3.33. Okay, so this column here is the 3's. So it's going to be that fourth column, 3.33. This one right here, I am coming up with, there we go, 0.996. So let's go here. And I would have to take 1 minus 0.9996, and that would actually give me 0.0004, right? That would be that area. Okay. Now you say, okay, well, hold on. What happens if I like the calculator? Remember where I'm starting off at. Starting off at 3.33, and I'm going all the way to infinity and beyond. So I'm going to go second vars. I'm going to go to my normal CDF. When I start at 3.33, comma, I go to a whole bunch of 9's, Close off my parentheses, hit enter. And okay, you see how we're coming up with this number and it looks kind of jacked up? The way this number is written, guys, this number is scientific notation, okay? So it says 4.34, and then it has a bunch of other digits, and then it has that e to the negative 4. So let me show you what this means in terms of an answer, okay? So I'm going to write it over here, just where I got a little bit of room. We came up with 4.34, and then there was an e with a negative 4, okay? What this means is this is 4.34 times 10 to the negative 4th, okay? And in scientific notation, what this number means right here is that we're going to take our decimal point right there, and we're going to move it 4 spaces to the left. So I want you to notice, I already have 1 digit there. And if I got to move 4 digits, that means I got to add 3 zeros. And isn't this number here the same as that number right there? And you would say, claro que yes, of course it is. Okay. All right. So let's take a look at number 3 and see if we can't figure this one out. Toyota Camry, it says braking distance on a wet surface is normally distributed with a mean of 149 feet. Looks like 149. I'm going to erase this a little bit so I can see it. Yes, 149 feet. And a standard deviation of 5.25 feet. Okay, so before I do anything else, first thing I'm going to do, guys, my average is 149. Oops. 149. My standard deviation is 5.28. Okay. The question is asking me, find the probability that a randomly picked Toyota Camry will have a braking distance between 140 and 149 feet. Okay, so probability that my X value is going to be between, 140 and 149. So the first thing we're going to do, we're going to change our X values into Z values, okay? So the first time, let's take our Z1. I'm going to call it Z1 because I got 2 of them. I'm going to take 140 minus 149 divided by 5.28, okay? So 140 minus 149, I know that's a negative 9, divided by 5.28. Oops, forgot my point, 28. And I'm coming up with a negative 1.70. Okay. My second value, Z2, is 149. So 149 minus 149 over 5.28. Well, 149 minus 149 is 0. 0 divided anything is still 0. Okay. So what we're looking for now is what's the probability that my Z values are going to be between 0 and or negative 170 and 0. Okay, so I'm going to mosey on over. Yes, I said mosey this way, and I'm going to draw a picture. Oops, move out of the way. Okay, let me draw a picture. So here's my standard normal curve. Okay, here's my mu is 0, and I'm looking at negative 1.70. And we are trying to find the area here in the middle. Okay, we're trying to find the area in the middle. So, a couple of ways I could do it, right? I can say, let me find the area to the left of 170 using my table, right? And then let me find the area to the left here, and then I would subtract those two numbers to find the area in the middle. But you know what? If the area under the entire curve is going to be equal to 1, right? Under curve is equal to 1, then wouldn't the area here to the left be 0.5, right? So if I just find the area to the left here, then whatever number that is, I can subtract it from 0.5. So let me come back to my chart. We're going to look for a negative 1.70. Let's let's see, where are we? Here we go. Where's the 0? Is it to the, okay, it's the last one on the right. So negative 1.70 would be this number right here, 0.0446. So we're going to take 0.5 minus 0.0446. Okay. So 0.5 minus 0.0446, and coming up with 0.4554. Right? Okay. If you decided that you wanted to do this using your calculator, remember, here's my lower limit and here's my upper limit, right? So I would come back over here and I would say, let's go to second vars. Let's do our normal CDF. We're going to start at a negative 1.70, comma, 0, hit enter, and 0.5554. Same thing, jelly bean. So we got it, right? All right, let me come back this way because we still got a couple more problems to do. I'm hoping, guys, as I'm going through these problems, that the idea and the process is becoming a little easier to do. I hope you're noticing it's becoming repetitive, okay? All right, so question number 4 says, using the chart above, find the probability that a member selected at random will have a cholesterol level between 220 and 255. Okay, so in this problem, here is my mean and my standard deviation. So remember, the first thing we're going to do is we're going to find our z-values, right? So remember, let me just do it this way. Z is equal to x minus mu over my standard deviation. So I'm going to find two z-values, right? The first one is when x is 220. So 220 minus 205 divided by 37.8. Okay. So 220 minus 205 divided by 37.8. And I'm coming up with, if I'm going to round this to 2 decimal places, I would say 0.40. Okay, because then after that 9 is a 6. So that's going to be 0.40. There's my first z-value. Okay, let's find our second z-value. Now we're going to take, what was the other one? 255. 255 minus 205 over 37.8. So I know when I subtract, let me move this over. 255 minus 205 is 50. Divided by 37.8. And I'm coming up with 1.32. Okay. So now what it is we're trying to do is, let's see. Get this here. Okay. So I'm going to draw my normal curve. Okay. Oops. It's a positive 0.40, isn't it? Okay, so we go at 0. So we're going to go from positive 0.40 to positive 1.32. And what we're looking for, my friends, is the area in the middle. Okay. So we're trying to figure out what's the probability that my z-value is between these two. Okay. So remember, if I'm going to do this on using my chart, if I find the area for 0.40, that's going to tell me the area to the left, right? So let me get my chart. 0.40, oops, 0.40. 0.40 is right here. 0.6554. Okay, oops. So this area, 0.6554. Okay. And then the 1.32, 1.32 is this area right there, which is 0.9066. 0.9066. And then we'll just take our calculator and subtract those two numbers. 0.9066 minus 0.6554. And I'm coming up with 0.2512. Right? If you want to use your calculator, you can always go second bars, normal CDF. Let's see. My lower limit is 0.40, comma. My upper limit is 1.32. Close it off, hit enter, and 0.2512, right? Because look at the number after that second one is a 6, so 0.2512. Okay. Alrighty, let me move this over a little bit. Okay, and we're almost done here, guys. Last part of this thing problem. It says out of 350 randomly selected U.S. men in the 35 to 44 age group, about how many would you expect to have a total cholesterol level greater than 260? Okay, so it's asking me to find what is the probability that somebody's cholesterol is going to be greater than 260. So the first thing we need to do is we need to convert this to our z-value. Okay, so I'm going to take 260 minus, we said our average was 205 with a standard deviation of 37.8. So let's take 260 minus 205 equals divided by 37.8. Okay. And I'm coming up with 1.46. 1.46, okay? So what we're trying to find now is what's the probability that my z-value is going to be greater than 1.46, right? So again, if I were to think about my thing here, right? Suppose right here, 1.46. I'm actually interested in finding the area to the right, but again, my chart, my t-value, my table always tells me the area to the left. So if I were to come back to my table, 1.46 is right here. That is 0.9279. So if I came up with 0.9279 to find the area to the right, I would have to take 1 minus that. So I could say 1 minus 0.9279, right? And I'm coming up with 0.07, was it 21? Yeah, 21, okay? And that's my probability. The question, though, is not asking me, can I find the probability? The question is actually saying, if we had 350 randomly selected U.S. men in this 35 to 44 age group, about how many of them would have a cholesterol that's greater than 260? So we'd say about 7.21%. 7.21% of the 350. So now I'm going to take my calculator, 0.0721, and I'm going to multiply it by 350, and that's actually going to tell me how many people we'd find. And so, guys, I'm thinking about this as people, right? I can't have 25.2 people. So I would say about 25 men, right? And that right there, guys, is 5.2.